manner. So our demo site, similar to all projects shown yesterday, we have a demo site, so we have a complete array of complementary demo sites reflecting the Mediterranean context, but also the key problem in terms of water quality, sedimentation, eutrophication, seawater intrusion, biodiversity loss, overexploitation. And we have also a site here in Crete, in Hania, led by Professor George Karatzas. So monitoring, I think we share, so we need data, we need innovative monitoring, so we need also to do it with local stakeholder. We can benefit from this next generation of high frequency monitoring. However, we have to tailor it to the context. For example, here we installed Zanzur in Tunisia, but you can see after 1 week, the Zanzur was full of sediment due to the sedimentation, and we have to be creative how we can deal with this kind of critical condition. So data has been generated. However, we need quality control, quality check to get better insight of the data. But also we are exploring other non-conventional way of monitoring. For example, here the camera system to monitor turbidity, and we have explored multispectral drones and trap camera system to see how much we can measure turbidity, which became a very serious problem in North Africa. And we have done a real river experiment with kaolin. So kaolin is kind of natural clay. So we have used this kaolin as a natural clay to create kind of turbidity event, and we have used our camera system to monitor that. And we have shown this RGB low-cost camera can satisfy this kind of application. So governance and socio-economical assessment also yesterday has been reflected nicely, and on all our demo sites we are considering this kind of living labs and stakeholder engagement, co-design of solution. Multisectoral water management also require innovative modeling, because traditionally we use a single model which can be hydrological or hydrogeological. However, our catchment has a different interaction. So our idea here, how we can integrate, and we use the hybrid modeling as mentioned also by Panos in the former talk. So we need to integrate more models together, building on the strength of each one when it's used separately. However, the optimization or the multisectoral water allocation needs also a framework where we can allocate the available water equitably among different sectors. Our strategy in OurMed project is not to use a single model. So the idea not to use a single model, however, to be flexible enough with our demo site, where together with their stakeholder and with the problem identified, they can select a portfolio or suits of smart model, use it in cascade or couplet, in order to satisfy what they are, where they are expecting. So nature-based solution also, or sponge application yesterday also has been mentioned, is critical and prioritized on our demo site. However, here we tried in our OurMed project to develop kind of cataloging, or how we can streamlining the catalog of NBS solution, which usually takes time based on the stakeholder consultation, but also our model capability, so how we can prioritize or select the best one. And our idea here built on prior knowledge of the catchment and improved or enhanced characterization, monitoring of the catchment, prior knowledge also about the problem and stakeholder expectation. We can do kind of first mapping catalog, which can be revised by stakeholder, and we can accelerate maybe the process. But also we need monitoring and evaluation of existing applied NBS solution. So we were lucky on Albufera system in Spain. Our colleagues based or building on former project, LIFE project, they have constructed the wetlands. and our idea in OurMed, how we can evaluate and monitor the efficiency of this infrastructure. So Albufeira system is very unique one, which buffer the flood, but also maintain water for migratory bird. However, has very strong legacy in terms of nitrate application on the upstream agriculture part, where groundwater nitrate concentration more than 250 milligram per liter, but also chlorophyll A within the lake is more than 90 microgram in the lake. So constructed wetlands has been done in a former LIFE project, and within OurMed we were monitoring evaluation downstream part of the lake. So as you can see, so basically in the red and the green bars here, we can see the concentration almost reduced by the half from the inlet of the constructed wetlands. And now within the project, we are discussing the business model. So how we can replicate this kind of good practice around the lake to improve the nutrient reduction. Early warning system also, I think, needed more and more, relying on freely available Earth observation data. So we have a company developed a smart app, smartphone application for farmer, where they can support them with alerting in terms of NDVI, but also NDWI, where farmer can receive notification, but also they can upload photo from their crops, but also the application allows them to compare their existing crop health with former years, where they know they have experienced that years and they can use it as a reference one. Also in terrestrial one, so Earth observation, so we are using Sentinel-2 for deforestation in Germany, but also the forest vitality or the reforestation again, and Earth observation was crucial also to be used in this kind of context. So one of our idea also how we can upscale all this kind of demo site, because yesterday also has been mentioned this gap between the demo site and the full-scale adoption of solution and technology. And one of our idea here to create kind of living lab around the Mediterranean, which we call it SustainMed, where we try to upscale and we gather different Prima projects to share experience, but also key stakeholder around the Mediterranean area to discuss maybe policy and solution adoption. So to do so here, for instance, we are also focusing on the regional scale, where we gathered one of the most comprehensive maybe groundwater level data around the Mediterranean. So we are still working on that exercise. However, we found only on southwestern Europe, Portugal, Spain, France, and Italy, the most complete data sets, where we investigated the groundwater trend in the region. And surprisingly, we found more than 68% of groundwater wells are more stable than previously thought. And this also gathering all single wells from different countries separately to have this database. But also when we try to understand the clustering of the different groups, this also shows the singularity and the difference between the different regions. The idea also to put this kind of data availability with the top line here, for example, the water timelines in Europe, which very straightforward, comprehensive. However, on the MENA region is very fragmented. And this also can be reflected by the data availability and the consistent and systematic monitoring and data sharing in the region. So in the next one also illustrate clearly, so in the north, so the Mediterranean is unique where we have the north and the south in the same region. And here clearly, so we have, even though I think they started both shores, they started early with the Barcelona Convention, but also the first environmental action program. However, in Europe, with the European enforcement, they have very complete, very straightforward policy. However, the south, little bit suffering from fragmentation, and this would be reflected also. Part of this regional, let's say, Mediterranean living lab, so we are trying to develop a Mediterranean water hub where we try to construct a repository or a dashboard where we put different Prima project results, but also any other available Copernicus or well-validated data from different sources. And our idea to make interactive platform here for a decision maker around the Mediterranean where they can see evidence or causality between different indicators. So my last example, I will be back to demo site application, which this digital twin platform. So it's obvious nowadays that we should take decision fast on the right time. And traditionally, our DSS tools are based on static and historical kind of scenario development. So our idea how we convert our basin, the physical understanding of the basin, to a digital twin system where we can forecast and we can observe different indicators simultaneously. So the Bode River Basin in Germany has been selected as the best example due to the experienced drought and the impact of this drought in the last few years, where we lost more than 75% of the forest on the Harz on 5 years. And you can see here this very dramatic forest loss close to the largest drinking water reservoir in Germany, the Rabbode Reservoir, where in few years you can see the total nitrogen concentration has increased or doubled in few years, impacting seriously the drinking water of the reservoir. So Tirreno, this is a German observatory we call Terrestrial Environmental Observatory. So the Bode is part of it, but also part of the ELTER presented yesterday. And benefiting from this high frequency data for more than 15 years is a very crucial element for the digital twin platform development. So we need also more other ingredients to develop this one. So we need modeling, portfolio, stakeholder engagement, but also we need a boundary condition or to understand the buffer of the system, which basically the recent drought experience also can tell us about the ecological boundary condition. So again, about the hybrid modeling, so we should not rely on a single model. So here the idea to couple hydrological MHM with nitrate stream flow, nitrate concentration, with mod flow groundwater level model, with ecological model, basically in terms of water temperature in the river and oxygen concentration using AI or data-driven approach. So here the workflow, how the digital twin has been constructed. So we have a lot of input data fragmented in different institutions. However, we are harmonizing all meteorological data, historical hydrological data, but also weather forecasting model result. So all integrated on the same platform. And simultaneously, we can give alert or notification or decision support system. To some extent, I think will be crucial to define the WEFE Nexus ecological boundary condition of our system. So with the right indicator, but also the right safe operating space. So where we are green, where we are safe, when we are risky. So here the system has been constructed, so we are working on that. Model results are running by today. So we have by today model result at different gauging stations. So here just to show you the comparison between the in-situ data and the model result in terms of discharge, but also in terms of nitrate concentration in different gauging stations within the basin. So the model has been validated, calibrated, and now we think we are ready to do the forecasting capability. In terms of groundwater level, also data and model results are very comparable. So we are updating by today all this data. Here, before I came to the meeting, so we ran the model by today, by 4th or 5th of March. So we try to do this kind of forecasting. And the last green here piece of projection is forecasting capability by the model in terms of discharge. But also here again, the discharge. So the green is the forecasting. So our model now working for the next 2 days. but we will extend it for the next 15 days using European weather forecasting forcing. Nitrate concentration similar, so we don't have the in-situ data synchronized with the platform, but here. And finally, our target to develop this kind of traffic light mapping, where based on the ecological boundary conditions, so we can see where we are from. So to conclude, we are organizing a similar event to this one in Tunis, called Sustain Tunis 2026. It's an international conference. However, OurMed will be also, the final meeting of OurMed will be organized on that event. I invite you all to join that event. So if you are interested, you can send an abstract and you can join that conference. It will be first week of June. Again, thank you very much, Nikolaos, all, and I would like to thank all our partners of OurMed. Thank you.